I will start this exercise by quickly examining the provided mass diagram. I can identify two large balance zones in this project as shown. We are given the economical hold distances of the three earth-moving equipment types used in this roadway project: the dozers, scrapers, and trucks. In part A, we need to draw the balance lines of the subzones of these equipment. I can draw the 200 meter economical hold distance of the dozers as shown, and I will allocate this balance zone subzone to dozers 1. The 600 meter economical hold distance of the scrapers can fit under the diagram as shown to mark the subzone of the scrapers in the first big zone. Although the trucks can economically haul up to 1600 meters, but the remaining part of zone 1 will only require them to haul the soil for around 730 meters. We can mark the balance lines for the equipment in the second zone following the same logic. Part B requires calculating the total haul quantities for the scrapers and trucks in both subzones. Let's mark the haul quantity of each equipment in each zone as shown. Although it's not required, but I will also show the haul quantities for the dozers. Now let's calculate each of these quantities. The scraper's total haul quantity equals QS1 and QS2. QS1 and QS2 equal the mass ordinate height differences between the scraper and the dozer balance lines in the first and the second zones. By finishing the calculations, we find that the scrapers are responsible for moving 2150 bank cubic meters in this project. We can follow a similar process for the trucks and calculate their total haul quantity to be 1900 bank cubic meters. Part C requires calculating the haul distances of the dozers and scrapers in zone 1. We know that the average haul distance is calculated by dividing the mass diagram area over the haul quantity. We can visualize the mass diagram area of the scrapers and dozers as AS1 and AD1. So we can apply the formula to calculate the average haul distance AHD for the scrapers and dozers in the first zone. The mass diagram area of the dozers equal the area of the hatched symmetrical triangle with a base 200 meters and mass ordinate height of 600 meters. So we get AD1 to be 60,000 bank cubic meter. From part B, we know that QD1 equals 600 bank cubic meters, so we will get 100 meters average haul distance for the dozers. For the scrapers, we'll need to use the trapezoidal area computation to deal with its compound shape. I'm showing here the trapezoidal area calculations following the process we learned in the previous lesson on earthwork quantity calculations. By the end of the calculations, we get 390,000 bank cubic meter for AS1. When we apply the AHD formula, we get 433.33 average hole distance for the scrapers in the first zone. The last part of this exercise requires calculating the average hole grade for the scrapers in the first zone. We are given the elevation change, EC, for the scrapers to be 30 meters between their cut and fill areas. We will apply this formula to calculate the average grade by dividing EC over AHD, values for the scrapers. By doing this simple calculation, we find that the scrapers will have an average hole grade of 6.9%. This is the end of this exercise. In future videos, we'll see how the average hole distance and grade affect the operation productivity and unit cost.